We present RealFlow, an EM-based framework to generate realistic optical flow dataset from videos. Recently, deep optical flow methods adopt large-scale datasets to train networks, which have achieved state-of-the-art performances on public benchmarks. One key ingredient of these deep learning methods is the training dataset. We summarize 4 key characteristics of the flow dataset: the quantity of labeled pairs, the quality of flow labels, the image realism and the motion realism. However, we find it is difficult for existing flow datasets to be satisfactory in all aspects. For example, flying things is purely rendered from virtual 3D graphic animations. Autoflow is a learning approach searching for hyperparameters to render synthetic training pairs. These methods can produce large amounts of training data with accurate labels but failed to meet the image realism and the motion realism criteria. Recently, depth-stillation is proposed to create training pairs from a single image. It randomly generates transformations as the flow labels, and generates training sample by image warping. In this way, the label criteria and the image realism are satisfied. But the synthesized images sometimes contain artifacts, and the generated motions cannot resemble realistic object motion behaviors. Different from previous methods, we propose to construct training pairs from the real-world video sequence. We estimate optical flow between 2 frames as the training label and synthesize a new image 2, so that the optical flow can be used as accurate label for image 1 and the new image 2. Then we use an EM-based framework to refine the generated samples to satisfy the realism criteria. Here is our EM-based learning framework. During the E step, we use an optical flow network and video sequences to create the training samples. During the M step, we use the generated data to train the optical flow network, which is used for data generation in the next E step. During the iterative learning steps, the capability of the flow network and the quality of synthesized dataset are gradually improved. The core of our framework is the realistic image pair rendering module, which is implemented by forward warping that can move the content in image 1 to corresponding location according to a given optical flow. However, there are 2 problems in forward warping: the occlusion problem and the hole problem. As can be seen from this toy example, the multiple sources problem occurs in the occluded region and the no source problem occurs in the hole region. Here we use the splatting method to deal with the occlusion problem by defining the fusion weight for foreground and background pixels according their depth values. For the hole region, we propose a bidirectional hole filling method to find its content from another frame. Here is the detail of our RIPR. Given 2 frames from real-world videos, we first estimate depth and bidirectional optical flow. Then we modify the flow maps by a parameter alpha and check the hole mask. After that, the splatting method is used to generate new views, which are further fused to render a new image 2. Finally, the image 1, the modified flow and the generated new view are used as a training pair. Here shows our experiments. We compare our method with previous dataset generation method depth-stillation. As can be seen, our method outperforms depth-stillation, which proves the importance of the realism of object motion behavior. Compared with unsupervised optical flow methods, our RealFlow can also achieve superior results. For comparison with supervised methods, we use Kitty 2015 training set to fine-tune raft model that pre-trained by our method. As a result, our method achieves state-of-the-art performance on Kitty 2015 test benchmark. We also use our generated datasets to train different supervised networks. Results are shown in the table, where the performance is improved for all these networks. Here is our ablation experiments, where we show the impact of different settings in our RealFlow. We also conduct the experiments about the EM iterations in our RealFlow. As shown in the table, the performance can be improved gradually during EM iterations. Here are some training pairs generated by our RealFlow. As can be seen, various samples with accurate labels can be generated by our method. To summarize, we propose RealFlow, an EM-based framework, to effectively generate large-scale optical flow datasets with realistic scene motions and reliable flow labels from real-world videos. We present realistic image pair rendering method for high-quality new view synthesis, overcoming issues such as occlusions and holes. We achieve superior performance over prior dataset generation methods and set new records on the public benchmarks using existing networks. Thank you.